Hi there, my friend. Welcome back. Today we're going to talk about statically indeterminate structures. What is the vertical reaction at A for the beam shown below? So this beam here has two fixed supports, and we have to calculate the vertical reaction at A. As we know already, these are statically indeterminate beams because every single fixed support has three unknowns. And we have two fixed supports, which means we have six unknowns and only three equations to solve them. So we have to do something else here. And what we're going to do, we're going to go to FE Handbook, of course, and I'm going to direct you to Civil Engineering under the Structural Analysis. You're going to scroll down a few pages, and you're going to find this member fixed end moment. Two examples here. They're going to give you a beam with two fixed supports. One of them has uniform load and one of them has a point load, which in our case, this is what we have. We have 2-point loads, but that's fine. We can easily apply the formula. So here they give you the formula for the moment at A and moment at point B. This is what we are going to work on moving forward. We're going to apply these formulas to our case. So to make this easy, I'm going to write, so moment at A, the formula was saying P A B squared divided by L squared, and moment at B, the formula was saying P A squared B divided by L squared. Okay, so let's go ahead and apply. We're going to say moment at point A equals 2. And we're going to take the 30 kips force. So I'm going to start with that, 30 multiplied by A for this force. If we go back to the handbook, A is this distance over here, from the support to the force. In our case, this is 4 feet. And then multiply by B, which is the distance from the force to the right support. And in our case, this is 12 plus 6 is 18. And this is squared. And all that divided by the entire length, which have 12 and 10, 22. So we're done with force number 1. And next, we're going to have to add to this moment force number 2. And we're going to have 20 multiplied by, and now A is the distance from the force all the way to the support A, and it's going to be 10. And then B is the distance from this force to the right support. And we have 12. And of course, 12 has to be squared, all divided by the entire length, again, which is 22 squared. And we don't have any other forces, so now we're going to say equals to, and this is all a matter of using your calculators and making sure you are inputting your data correctly to get the right answer. And once you do that, you should get 80.3 for this first force plus, and then this value over here, the next, is equal to 59.5. And the final value is 139.83. And these are kip foot. Great. We're going to go ahead and do the same thing for point B. We're going to calculate the moment at point B. Moment point B equals 2. So now we're going to apply this formula on the right side. And I'm going to start with the 30 kip force. Now I'll have 30 multiplied by A, again, is 4 feet. Just in this case, A is squared, so 4 has to be squared, multiplied by B, which is 18, all divided by 22. We're done with first force. Next, we're going to have to add the moment by force number 2, so 20 multiplied by A, in this case, is 10 and is squared, and 12, and okay, 22 squared, and here 22 squared, I forgot the squared, but the calculations are correct. So 22 squared equals, so again, make sure you input your data correctly in the calculator because it's easy to make mistakes. And so the first value here, this one, you're going to get 17.85. And for the second one, you're going to get 49.6. And the final value is 67.4 kip foot. So now we have the moment at both supports. So now that we have the moments, the only unknowns here are actually the vertical supports. The fixed supports also have horizontal reactions, but in this case, we don't have any horizontal forces, so the horizontal reaction is going to be 0. So the only unknowns are going to be the vertical reactions. So now we're going to input these moments onto our beam, just like that. And the reason it's going downwards like that is because in the FE handbook, actually, they show you the sign of the moments at A and sign at the moment, or the direction of the moment. So this is exactly what you do in your case, going this one counterclockwise on the left and clockwise on the right. And the value for each moment, I have inputted it over here. The forces remain in the same spot. And now we are going to add the reaction at A, a reaction at B. So the only thing we have to do, if I go back and I look at the question, the problem is asking what is the vertical reaction at A for the beam shown below. So we have to calculate this reaction at A. So the way to do it, of course, we're going to take moment at point B equals to 0. Moment at point B equals to 0, this result. And I have mentioned this before. Now we are going to choose our positive and negative sign or direction. I'm going to take that counterclockwise is going to be positive. And I'm going to start with this moment, 139.8. And this is a moment, which means I don't have to add a arm to the moment because see the moment has already kip and foot into its units. And next, I'm going to have the 30 kip force, which is going to be 30 multiplied by its arm, which is 6 plus 12. It's going to be 18. Plus another force that is counterclockwise direction about point B is 20 kips. So 20, and the arm for this force is 12 feet. And next, I'm done with this moment, and then 30 kip force, 20 kip force, and I'm noticing I don't have any other force in counterclockwise direction. I have added them all. Next, I'm going to go and use RA, which is counterclockwise, or add RA. And the arm for RA is the entire length of the beam, right? Because we are taking the moment about point B. So the length of the beam is 22 feet. And minus, we have this moment at support B. and the value for this moment is 67.4. And if some of you, might ask, why are we taking the moment? It is right at point B, is because the moment has no arm, so I have to take it. It's not the same as if it was a force. If I had a force here, like in this case, RB, I am not using RB or not adding RB into my equation because RB goes through this point, which means it has, or its arm is 0. But the moment I have to add it. So minus 67.4 equals to 0. So I'm going to calculate from this equation for RA. And RA is going to be equal. I'm going to have 22 over here. And at the top, 139.8 plus 30 times 18 plus 20 times 12 minus 67.4. And again, you guys use your calculators, get used to that. Once you do it, you should get a value of 38.75 kips. And this is the reaction at point A. Now we could go ahead and calculate for the reaction at point B. And if you want to, do some exercise, you can go ahead and do that to get used to it. But the problem is only asking us for the reaction at point A. So we don't have to do at point B. And 38.75 is approximately 39 kips. So 39B is our correct answer. And there you go. Wonderful. That was pretty much it for this problem. I guess it's pretty simple if you know where to look for the formulas and you know how to apply them and how can you get the reaction after that. All right. Thanks for watching. If you found this video helpful, don't forget to subscribe and give it a like because this helps put this video in front of more people just like you. Until next time, keep practicing the FE problem. See you next week.